I'm breaking everything tonight, everybody. How's everybody doing? Let's stop that music. I got a copyright strike on that uncopyrighted music last night. I can't get over the music. Well, sorry for the kind of long wait for the intro, guys. Hold on, let me close my door real quick. It's going crazy. Hey, can you make me a big, can somebody make a big glass of iced tea for me real quick? Yeah, I was having some difficulties getting, Photoshop opened up for some reason. Kind of weird. I don't know what happened to, I've been using Photoshop all day today. For some reason now it don't want to work. That's fine. You can do it out, I guess. Maybe. I don't know. Yeah, it's all good. How's everybody doing? Hope everybody's having a good day today. I'm doing quite well. Today we're just gonna be hitting subnetting hardcore today. I kind of felt as though last night really didn't go too well. So today we're gonna be taking it up, taking it to the next level, and we're gonna be nailing subnetting real hard today, because that's what we're in right now. We're in subnetting, so we really need to yeah, we just have to do, we gotta get our heads wrapped around let me see what I'm looking at. Yeah, that's a good one. All right, we gotta get our heads wrapped around subnetting. That's the biggest topic today, and that's what was in the title. So we might as well just jump right into it. And today we're going to be using Cisco Packet Tracer. So I got my my Cisco Packet Tracer lab up and running. I'm still curious why I could not get Photoshop to open. That's just so, for me, that's kind of like strange and aggravating at the same time. Weird. Let me try one more time. Huh. That is so strange. I don't know if it's because I got the cameras on, maybe. Photoshop don't like cameras. I don't know. But that is so strange. Like I said, I've been working on Photoshop I always work on Photoshop. Photoshop's my thing, and I don't know why it's broken all of a sudden. That is so strange. Every time I click on it, it just does nothing. Huh. I broke Photoshop today. Amazing. Epically amazing. That's fine. But yeah, that's a kick in the butt, because that's what I wanted to use tonight to for what we're gonna be doing with subnetting. But that's fine. I'll just use Paint. Paint's fine. I can do the same thing in Paint. Yeah. All right. Without crying over my inability to Photoshop, let's jump right into things, guys. All right. Oh, not that scene. This. All right. So we're here. Let me full screen this, and let's get this. Let's get this all the way to this screen. All right. So, how does I really use? As you can tell, I probably don't use this too much. All right. So we're gonna be taking the deep dive into subnetting today, guys. All right, and it's not gonna be too bad. We're not gonna jump into the book tonight. We're not gonna do anything like that. I got some cool stuff though. I should be starting work tonight. That's a big thing, you know. Hold on one second. Sorry about that. I'm running around like a maniac. I just got dinner done. Just got dinner done for me and the kiddos, and yeah, I'm just trying to get used to my new schedule, because and I'm gonna try to do my best not to alter the time on the stream, but I may. I may run into an issue that I might have to alter the schedule for the stream. Maybe. And I hope you guys understand that if I have to. Just because I don't want to be putting myself out too far out where I'm absolutely getting no sleep anymore. Because that's not good for anybody. You know what I'm saying? Joe without sleep is a madman. Least words. So, but other than that though, like I said, things are going good though right now, guys. Things are going good. Things are like I said, things are really starting to come together. It's just getting used to gonna get used to the new schedule where everything is, that's it. You know what I'm saying? Because I'm even running into times now where I'm running to get dinner and everything else done right before I jump on here. And that shouldn't be the case. I shouldn't be rushing. I shouldn't be rushing around to get everything I need to get done, and just having enough time to just to get on this and do my thing on this. You know what I'm saying? I hope that's making sense to you guys. If it isn't, I'm sorry. That's kind of where I'm at though. Take a sip real quick. So, like I said, it's gonna be pretty chill though tonight. We're just gonna be sitting back. We're gonna be hitting subnetting together. And I hope I introduce it in a way that you guys can understand it. I feel as though the method that I'm going to go over tonight has been a great method for me personally, to really wrap my head around subnetting, because subnetting is one of those tough things that if it isn't explained correctly, it can be very, very, very hard to understand. And I'm dropping everything. I got all of these. I'm like an epic mess sometimes, guys. I don't know what it is. You guys probably know what it is, because Joe, you're just a mess. All right, so I got that ready. Put that there. My pens. I don't need my pens right now for anything that we're going over. Get my scrap paper out of the way. I move my keyboard out of the way. And my minion. Okay. All right. So let's dive into it. Phone. Put you right there. Cool. All right. Let me just make sure this works good. All right. That's cool. So size here. So yeah, 192.168. All right, so this is working pretty good there. I'm happy with how this is gonna work tonight. Okay, yep. All right, so then I can select things. All right. Whoa. Let's not do that. I should not do that, man. I don't know what I did. All right, that's cool. All right. maybe we use that. I'm just gonna put that off to the side for now. All right. So I know where I want to begin, and this is where I want to begin. Again, let me apologize ahead of time because I'm gonna be munching on my food and everything else while I'm doing this. It stinks because I had everything set up in Photoshop, like I said. So this is kind of throwing me a curveball. It's fine. I'm good though. All right. So what I want to build first is I want to build a couple things. I want to build a couple things first, so you guys have some. So we have some visuals. We have some visual things that are just going to help us in the beginning process of what we're going to be doing. All right. So don't mind when I do this. I'm just doing this because this is going to help us. So 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. One, two, three, four, five, six, seven, 8. 4, 5, 6, 7, 8. Hopefully, can I edit this? No, it's not gonna edit that. That's yeah, it's okay. 1, 2, 3, 4, 5, 6, 7, 8. Bear with me for just a couple minutes, guys, and this will make sense very shortly. I promise you. Eight. Need another hot Q buttons. I don't know the hot Q buttons yet, but I'll figure this out. All right. 1, 2, 3, 4, 5, 6, 7, 8. And I hope you guys are starting to see where I'm going with this. If you don't, then we'll see you in a second. I'm gonna start doing this a little bit faster. 16. 2.5.2.5.0. That's it. Let's be lined up. This is not at all. One second, guys. Take this ball real quick. Sorry about that, guys. I decided to take a quick phone call. Like I said, whew, I'm a busy boy. That's why I seem like yesterday when I seemed kind of flustered. I apologize for that. I just been, like I said, I just been, oof, like everything's good, but everything's just coming way real fast. So it's all good though, man. Good things. Good things, my brothers and sisters. Good things. Like I said, I should start picking this up right now. So, all right, let me just copy and paste this then. Come on, that's it. There we go. Boom. Put you right there. Put you right there. Put you right there. You'll see very. A second, guys. That's pretty. That's it. That looks good, right? All right. All right. I didn't need this whole. Oh, this one's gonna be all ones. Delete this. Go back here. This is /4. Yep, 2.5.2.5.2.5.0. 2.5.2.5.2.5. This one. Bit. All right. Now let's do this. Right. Try to make sure I spell binary right. Awful speller, guys. Huh. Awful speller. Slash notation, prefix. Yeah. This would be DDD stands for dotted decimal notation. So DDN, dotted decimal notation. So DDN, okay? All DDN stands for is dotted decimal notation. Okay. So, this will be the first. This is going to be one of the first things we should be looking at, okay? Now, what I've done is we need to start off on the easy. We're going to start off with the easy subnetting, okay? So we're going to start off with easy. The easy subnet masks, and then we're gonna move as we progress. We're gonna move into the more difficult subnet mask. All right. I'm pretty impressed that So there we go. So let me just. We're gonna take this whole entire picture, shrink it down. All right, but this will be ours. This will be ours that we're going to use as we go along. So that's number one. All right. So we're going to keep that there. All right. And then, yeah, that was good. That's good for us for now. All right. That's good. That's a good one for now. Now what we can do is, let me see if I can just stretch it out. See, it looks like crap when I do that. All right. Maybe like that. I just didn't want it to take up the whole. I didn't want it to be in the middle. That's good. All right. So that's cool. Let's move right along then. So what we have here, all right, this is the binary. This is we're going over subnet and subnet mask, okay? So when we're dealing with subnet masks, the order in which we're dealing with the particular masks. Let me get my Epic pen up here. I think Epic pen just broke too. Did it break? It broke. Man, I swear, I'm breaking everything tonight. I can't seem to yeah, I can't seem to win right now. It's epic. There we go. All right. I just needed Epic Pen so I can draw on this now. So I don't have to redo it all over again. Even though I messed it all up by shrinking it and manipulating it and stuff like that. That's the joys of, that's why I wanted to use Photoshop. Because Photoshop doesn't really mess it up as bad as I just destroyed it. So that's fine. So obviously, so we have binary, okay? So this is binary. When we're dealing with how we're going to be dealing with our masks, all right? Everything, so these are octets, okay? Octet is 8, okay? So 1, 2, 3, 4, 5, 6, 7, 8, okay? Now remember, in binary, there's only ones and zeros, on and off, ones and zeros, okay? So all right, either my light, can you guys see my light? Let me put it red. All right, either my light is on or it's off. On or it's off. Okay, that's binary. On is 1. We're just going to say on is 1. So that's 1, that's 0. That's 1, that's 0. That's 1, that's 0. That's binary, okay? Now, that is what, that's like I guess the simplest form. That's just how computers, know. They only know on and off because computers only work by electricity, okay? So if you're an electrical engineer, if you know anything about electricity, the switch can only be in 2 states. It's either in the on state or in the off state. So that turns into a mathematical equation when you're dealing with computers, okay? That's how that's the source of binary. Either it's in the on stage or the off. So ones and zeros, on and off. Okay. So if we can get past that, and I don't want to get, I guess, too deep into teaching binary here, because that I might just take forever trying to explain binary to everybody and the history of binary and whatnot. So I don't want to get too hung up there. All right. So let's move past. Let's move past that. Okay. Now what we got here is the prefix length. All right. And how we get that prefix length is we have 8 binary ones followed by 24 binary zeros. So we only are counting the 8 binary ones. Okay, cool. So since we have 8, we have a prefix of 8. All right. If you work this equation out in binary, 8 binary ones followed by 24 binary zeros, you're going to get 255,000. Okay? 255,000. Okay? Because 8 binary ones is 255. Okay? Obviously, 8 binary zeros is 0. 8 binary zeros is 0. 8 binary zeros are 0. Okay? So, prefix is the amount of how many binary ones we have. Okay? So since we have 8 binary ones, again, I'm just starting off here. 8. Okay? Now, 8 binary ones equals 255. Cool. Let's move on. Next one, 16. Prefix is 16. So we have 8 binary ones followed by 8 binary ones. 8 plus 8 is 16. Okay? Again, 8 binary ones equals 255. Another 8 binary ones is 255 plus 16 other binary zeros is 0 and 0. Okay? Same thing. All right. We have 24 now. So 8 plus 8 plus 8 is 24. All right. Then we have another 8 binary zeros. Okay. So in binary, that equals 255, 255, 255, 0. Very good. So we have 8 binary ones in each octet. So we have 3 octets. So 1, 2, 3, 3 octets. 8 plus 8 plus 8 equals 24. That's how we get that 24. The /24 notation. And that's how, when you guys see me, I'm putting in those addresses, the 255, 255, 255.0. That's in the 24 / notation subnet mask. Okay, the prefix / notation. So prefix / notation subnet max, that would be equal to 24. Or the dotted decimal notation is 255, 255, 255, 0. Or in binary, it's 1111111 dot 1111111 dot 1111111 dot 0000000. Okay, all right. I probably messed that up, but whatever. Okay, let's move on. Now we have an entire 4 octets full of binary ones, 4 8s plus 4, 8 plus 8 plus 8 plus 8, okay, that equals 32, okay, so 8 binary ones plus 8 binary ones plus 8 binary ones plus 8 binary ones, you'll come up with 255, 255, 255, 255, okay? And that's how we get the dotted decimal notation of 255, 255.255. All right. The prefix subnet mask notation would be 32. Okay. This is where we're starting. All right. Now that's just a quick overview of binary and how we're getting these subnets in these subnet mask notations. That's how you're seeing these amounts right here, and then that's where you guys are seeing these numbers come from. Okay, because at the end, because it all comes down to binary. Okay, all right. let's move on. So, what what we need to do now, though, is we want to discover, we want to start subnetting. All right, we want to start creating subnets. All right. And the reason why we want to do that, jump back on my Windows PC I got up in here. So we're in Cisco Packet Tracer, okay? And let's grab some routers. All right, get some routers. Now I know I did a topology last night. That topology, I wasn't too happy with how I did that last night, and I kind of, again, I want to apologize to everybody how I was just off last night. I've been trying to get my head around how I'm gonna get used to what are these routers? What kind of router is this? So we have our routers, and what we need, what I'm going to do, we're gonna set up a sweet little topology here. Actually, you know what I should do? Let's move all these over here, and then we're gonna have a whole nother. We're gonna actually set up something pretty neat. Man, I'm a hot potato mess today, I swear. Sorry. All right, just had some good folks. Again, just some good folks helping out the family. Gotta run outside and meet them real fast. That's it, guys. All right. Cool. I'm a hot mess today. I'll tell you. Let's get back into it, guys. So, what we were just talking about is the purposes and the reasoning for subnetting. So, what I was designing and what we're going to design is a better topology than what I was creating last night in CML. And the reason why I'm going to be doing it in packet trace is a couple of reasons. Is because of the I guess the scope of the topology will be a lot on my PC to handle. So to save my PC from exploding tonight, and let me just refresh this. Save my PC from exploding tonight. That's the reason why we are going to be doing this in packet trace. So let's all right. What do we got? So we're gonna have a WAN link. So let's go over here. So serial here. Gigabit 0. I gotta add a serial port to this. That's why. Stop. 6 serial port. Internet. So the power's off. On now. Serial port to this. It's off. Serial port. Turn it back on. Oh, did I turn it back on? So now let's add a serial. So this is going to be representing our WAN. Okay. That's representing our WAN. All right, our wide area network right there. All right. You know what I need to add? Yeah, it's more. Can I add some more to this? Add some more to. That's a switch port. I don't want switch ports. That's. Another one of these, mine. Wonder if I can remove these though. Can I remove these? No. Add more to you. Switchboards. Huh. I'm wasting too much time on this. Add some more pictures to my. All right, so I guess I could just add a. You can just add a switch there. Uh, 60. Kind of interfaces does this have? That'll work for us. And back on. Let's make connections. Figure it. 2, 1. All right, so we made our connection. Sorry about wasting everybody's time. But, this, let's see, and we're gonna give everything some names. This is gonna be. I'm gonna remove. Let's do this then. Let me go to our settings, preferences. And I don't want to see that. Okay. Cleans that up a little bit. Still going to show us some names. That's fine. I'm going to say when. All right. I'm going to say, well, actually, let me give this one when inside. And outside. Okay. And this can just be which one? I'm just going to call it. All right. And this one's going to be area 1. Actually, let's call it area. Yeah, we're going to call it area 2. Three. Get all of our areas. They're up now. All right. So this is one. So we're just getting this set up now so we can get into why subnetting is going to be so important once we get to our next stages. Okay. And then also what I want. Guess what I could have as well is another router. It's going to be stop. Oh. It's going to be our server farm right here. So I have 2 servers over here. All right. You boot it up yet? This is going to do DHCP services. All right, just switch. Hold on. Website. Did. So that sort of what I'm doing. And no, what we need. These guys. Booting. Switch. One switch. Two switch. Three switch. And go to end devices. Let's grab some PCs now. Yes. Once we get everything set up, we'll remove all the interface labels and whatnot. But this is setting up kind of the topology that we're gonna need so I can properly, again, what I was doing last night in CML, yeah, it kind of represented whatever. But this will give us a better representation. But we still need to go back over though, because again, we still need to talk about subnetting and how come up with subnets. So let's do it. We're gonna leave this alone for a second. Let's get back over to Photoshop. All right. So to understand, let's grab a let's take an IP address, okay? Let's say 10.100.100.25, okay? And we're going to say that has the /24 subnet mask notation, okay? Cool. All right. So if that right there has the /24 subnet mask notation, okay? All right. If we go back over to our graph here, our little image here, what we kind of see is what we're going to do is one of the rules is where all the binary ones will maintain the same. So what's going to happen is this will be our network, okay? Now I've gone over this a couple of times. So, and then this right here is our actual host, okay? All right. So with that then, what we can surmise, increase this just a little bit, is 10.100.100 is the actual network, okay? So that's the actual network. So the network will be 10.100.100.0. That's our first. So this is how we start coming up with our networks, okay? All right. This right here is the subnet network, if I'm saying that right. All right. Now, to get the range of addresses that's within this network, all right, what we would do then is we would fill the rest of these with ones, but not the last bit. So it would turn into 10.100.100. Well, to get to broadcast.255, this would be the broadcast address, okay? And then the very last address that this network has is 10.100.100.254. All right? I think I'm kind of going over that wrong. I'm not going over it wrong. I'm just explaining it in a hard way that I should not be explaining it. Let's go back. All right. Let's draw something. We need to draw something else. We definitely need to draw something else. What I need to draw is, let's do this then. Let's draw a couple lines. Let's be that first line. Our second line. Our third line. Okay, fourth line. All right. And do that again. I don't have to do it. I just copied this all. this. Let's do, yeah, 1, 2, 3, 4, 5, 6. Need a couple more. So let's start here, and I'm gonna give this this is gonna be titled mask. Okay. This is gonna be titled address. All right. This will help us, guys. Subnet ID. Instead of me just trying to bounce all over the place, let me just do it like this then. All right, this is going to be first address. Last address. And then broadcast address. All right. So we got mask. That's what we're going to use. So the subnet mask, okay? So we're going to identify the subnet mask. We're going to input the actual address that we've given that we're going to play with. We're going to find the first subnet ID. So we're going to find, well, not the first subnet ID. We're going to actually find the subnet ID. Then we're going to find the first address in that range. And then we're going to find the last address in that range. And then the actual broadcast address, okay? Let me just fix this alignment just a little bit better. Cool. Good for me. Well, we're there. All right. And I'm gonna use this guy for our demonstration purposes. So let's give ourselves an address. Let's give ourselves an address, and it can be within, it can be whatever. So let's say, but we're gonna be using easy addresses first as we begin this. Okay, guys. So let's just say again 10 dot whatever. We're gonna say 10.100.100.50. Okay, and again that's gonna be in the /24 /24 prefix / notation. So the slash the prefix, the subnet / notation. That's what the 24 is representing. Okay, and from there, so this is going to be our address. Okay, so that's our address. All right, so what we need to do then, let's come over here, and let's write down our mask. So since we know it's 24, our mask then is going to be 255. All right, 255, 255. All right, and it's going to be 0. Okay, all right, so that's our mask. Okay, and that's represented, all right, by how many binary ones? All right, followed by binary zeros. Okay, so now the first rule is when we have a binary 0 in our subnet mask, that number, so this number right here, all right, is going to fall off. All right, and that's going to become a 0. Okay, So let's come back over here now, and let's just write our mask ID. So we got 10. All right, 10, 100, 100, and we're just gonna put 50 here. All right. And now what's gonna happen is that since there's a 0 there, this now is gonna become a 0. Okay, so now our subnet ID is gonna be 10, 100, 100, 0. All right, so our subnet ID now is 10.100.100.0. So our new address is 10.100.100.0. So this is our subnet ID for this address range, okay? Now the first address in that range now, all we have to do is +1. All right, so we just have to +1 here, okay? So there's going to be 10, all right, 100, 100, and 1. All right, so our first ID now is 10.100.100.1. So that's our first actual address ID. Now let's go down to the very last part though, and let's figure out our broadcast address. So it'd be 10, 100, 100, and 255. Now, what we're gonna do to always find the broadcast address, what you're gonna do is you're gonna fill the rest of the network portion. So remember, this is our network portion, the 50. All right, that's identified because all of these are binary zeros. To find the broadcast address, what we're going to do is we're going to fill in the rest of the host portion with binary ones. Now remember, 255 is 8 binary ones. So all we did was we taken the very last address in that range, and we filled the rest of it with binary ones. Okay, equaling 255. And that's how we come up with our broadcast address. Now, to get our very last address in that range of addresses, all we're going to do is we're going to minus one of those binary ones. So it'll be 1111, 1110. Okay, that equals, and that's going to give us the address of 10, 100, 100, 254. All right. So our very last address within the range of these addresses is 10.100.100.254. All right. Our broadcast address is 10.100.100.255. All right. So what we've done is we found our subnet ID, our first address in that address range, our last address in that address range, and then the broadcast address for that subnet ID. So the subnet ID for 10.100.100.50, so 10.100.100.100.50, its subnet ID is this. All right. The broadcast ID for that address is this, 10.100.100.255. Okay. So let's do another. We're gonna have to do a couple examples, just so this can make sense. Let's do a new address now. Again, we're gonna keep with the same kind of reason in here. So let's go 172.16. Remember, we're gonna just stay with private addressing ranges. So I'm gonna say 25 and 50. All right, and we're gonna say slash. I'm going to say /16 on this one, okay? All right. So 172.16.25.50.16. All right. If we look up here, 16. Now remember, we're just sticking with the easy ones. We have two sets of binary ones. So we have 1111111 and 1111111. Okay. So we have 2 octets that are full of binary 1s, and then we have 2 octets that are full of binary 0s. So what that's meaning is 172.16 is our network, okay? 25.50 is the host. All right, that's identifying the actual host. These are the host bits. 25.50 are the host bits. 172.16 are the network bits, okay? So let's write our mask down here. So we got 255, 255, and then this is 0, and then 0. All right. Remember the address is 172.16, 25, and 50. All right. Now let's find our actual. Now remember the rule is when we have a binary, when we have a 0 on our dotted decimal notation, when there's a 0 in our masks, these turn to find the subnet ID. It's just easy. It's as simple as these now become 0. So it'd be 172, 116, 0, 0. All right. Now this right here. Oh, we just got a follow. Good looking out. Asher. Oh, hey. Azer. Thank you for the follow. How we doing? All right. So to get back to what we're talking about, so now the subnet ID for the address 172.16.25.50, the subnet ID for that address range is now 172.16.0.0. So that is the subnet ID for this address right here. Okay. Now let's find the first address, and that's all we have to do. All we're doing is we just have to plus 1 to our subnet ID. So all we're doing is plussing 1 to our subnet ID. So it's 172.16.0.1. Okay. So the first address in that range of addresses is 172.0.1. Okay. All we have to do to find that first address is now plus 1 to that subnet ID. Okay. All right. Now let's go find our broadcast address first. Okay. Now remember, logic is all what we have to do to find that broadcast ID. All right. What we need to do is we need to fill the rest of these host bits here. So the host bits 0 and 0. All right. Because remember, we're still here. All right. So we're in 16. So we have the last 2 octets of that subnet mask. All right. All we need to do is we need to just fill that with all binary 1s now. Okay. Now 8 binary 1s equals 255. Okay. All right. So our broadcast address will be 172.16.255.255. Okay. Let's write that down now. This is our broadcast address, 172.16.255.255. All right. Now, to find our last address within that range, all we have to do is minus 1. We have to just take away 1. All we're doing is taking away one of these binary 1s, the very last binary 1 in the last octet. Okay, in the last octet. Okay, remember there's 4 octets. All right. All we're doing is this very last octet. We're gonna replace it with a 0. Okay. All right. So just to keep things easy, is we just have to minus 1 from the broadcast address. So it'd be 172.16.255.254. All right. So our last address in this range is 172.16.255.254. All right. what we've come up with is for the address range of 172.16.25.50, the subnet ID for that address is 172.116.0.0. The first address within that range is 172.16.0.1. The last address for that range is 172.16.255.254. And then the broadcast address for that address range is 172.16.255.255. Okay? All right. Let's do another example. All right. Now this is the easy subnet. This is easy subnet masking. Okay? Because the prefix length of 8, 16, 24, and 32, as you can tell, the octets are either full of binary ones or they're full of binary zeros. Okay? Those are the easy subnet masks to come up to create this formula to do your subnetting. These are the easy ones, okay? Now once we get to the harder ones, it's not the fact that it's harder, it's just now we got to do some math to figure out those subnets, okay? But for now, we're just going to keep with the easy ones so we can just figure it out together and work this out, okay? All right, let's erase everything again. Let's come up with a new address now. All right, I'm connected, right? Yeah, I'm connected. Cool. Just want to make sure I'm still connected to my thingamaboober here. All right. So let's come up with another address. What's going to say 192.168 whatever 75.16. Okay, and we're going to say this is in the subnet mask, and this is we're going to say 24. Cool. All right. So we're saying 24. So the dotted decimal notation for the subnet mask 24 again is 255, 255, 255.0. So 255, 255, 255, 0. Okay. Let's write down our address 192.168.75.16. So that's the address that we want to find this information for. Okay, so we're just looking for the information. So again, to find the subnet ID for 192.168.75.16/24, again, to find that subnet ID, what we're going to be doing is the subnet ID lives in where all these binary ones are. Okay, so since we already know that in the /24 notation, the first three octets are full of binary ones, so 192.168.20.75, this is our network. All right, the 16, all right, the 16 lives within the octet that's full of binary zeros. Okay, so it's as simple as, all right, you take away 16 and that becomes a 0. Okay, so 168, 75, and 0. Okay, so our subnet ID for 192.168.75.16, the subnet ID is 192. All right, 168.75.0. All right, very good. All right, now the first address, remember, all we have to do is +1, because all we're doing is we're on this very first octet, we're just adding 1. All right, to find that first address, we're just adding 1 to that very, very last octet on the very, so 1111 1111 dot 1111 1111. All right, and we're on 1111 1111. All right, dot 00000001. All right, so all we're doing is adding 1 to the very last binary bit in the last octet. That's it. That's it. That's all we need to do to come up with our first address. Okay? So this would be 192. All right. 168.75.1. All right. And that is our first address for this address range. All right. Now let's find our broadcast address. So remember, for our broadcast address, all we have to do is we have to fill the very last octet with binary 1. So we have 11111, 1111, 1111, 1111, 1111, 1111, 111. Okay? Now, remember that equals 2 for 5, 2 for 5, 2 for 5, 2 for 5. Okay? So, what's going to happen now is we're going to have 192, 168, 75.255. Okay? This is going to be the broadcast address for this address range. Okay? Now, all we need to do to find the last address within that address range is we just take this very last octet, we make it a 0. So 11111, 1111, 1111, 1111, 1111, 1111, 1111, 1110. Okay? All we're doing is taking one of those binary ones, and I think I put way too many ones somewhere. Whatever. It'd probably be easier if I do by 4s anyways. 1, 1, 1, 1. So you guys can just see this a little bit better. 1, 1, 1, 1, 1, 0. All right. All you got to do to find the last address within that range is you take the very last binary bit, and that broadcast address. All right, and you just turn that back into a 0. Okay, so that gets us 192, 168, 75.254. Okay. 192, 168.75.254. All right. Very good. So far, so easy, right? So far, so easy. All right, but this is the easy part. All right. All right. Now, I guess we can just stay with easy, and then tomorrow maybe get into the harder ones. All right, let me just see. Let's come up with a couple different address ranges. Yeah, let's come up with a couple different address ranges then. And then we'll take these address ranges and we'll plug those into packet tracer here. So what do we got? So we have area 1, area 2, area 3. All right. We also, this is an area. Okay. Then this is an area. Let me clean this up a little bit and use a different color. All right. So we have, this is an entire area. This is an entire area. This is an entire area. All right. This right here. So 1, 2, 3, 4, 5. All of these links. This is a whole entire area. All right. Yeah, because that's connected there. And then this is an area, and then this is an area. Yeah. Might have to. I hate the fact that I just couldn't hook it up to the. There wasn't enough interfaces on that switch. So what I could do though is we can make VLANs. Yeah, let's do that. We can make VLANs with this switch here. So this will be an area. This will be an area. This will be an area, and then this will be an area, and then this will be an area. All right. And then we won't do anything there, and then we won't. Yeah. So the only switch that will configure VLANs on is this switch right here. All right. So we got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. We got 10 areas. All right. We have 10 areas that we're gonna need. We're gonna need subnets in. Let me go back to the Zoom so you guys can see this a little bit better. Ooh. Grab that. All right. Yeah, you guys can see that pretty good. All right. So we got 10 areas. We got 10 total areas that we're gonna need they're gonna need their own network, okay? Their own subnet ID, their own broadcast ID, all right? So what we need to create is we need to start subnetting this out. For this entire topology to work, we need to think about our addressing, okay? So let's start thinking about what we want to do for addresses here. Let's take a look. Because we don't want to be wasting a lot of addresses where we have link to links. All right, we don't want to be giving an entire range. I mean, I guess for now we'll keep it simple, and we might just to keep. I guess yeah. For tonight we can do a simple one. Tomorrow though, we'll do it so it can actually nearly represent how you would create these links. All right. So let's, I guess, to keep everything in an easy way of thinking is, let's start. Where do we want to start? Area 1. What do we want to give? I guess this first link here. This is our WAN link, okay? So this is our edge router going out to the internet here, okay? Now, if this is our edge router going out to the internet, this interface here, you know, that's going to have a that needs a private address. No, a publicly facing address. Let me take that back. A publicly facing address, so it can be routable on the internet. Everything in here though is going to be privately addressed. This one interface needs a publicly routable address, so it can be publicly routed. All right, on the big internet. Okay, so we'll give that a we'll give those two interfaces the, I don't know. Let's just go with we'll just say, I guess anything. It don't really matter. It don't matter. So we'll just say 1-1-11-11, say 0/11. Okay, that will be our public routable. This is the address that I guess that we got from the IEEE. Okay, we got the 111. We got the 11.11.11.0 /24 address. Okay, so this interface will have this address range so we can communicate out to the actual internet. Okay, but this first, so as the network engineer, now we're inside of our network, and now we're going to start adding some address ranges. So we're going to say 10 dot. We're going to say 10 dot. Let's keep this, I guess, super easy. 0-0-0. All right, say /24. All right, again, I'm going to be wasting a lot of addresses, but I'm going to try to keep this super duper simple. And then on this interface, I'm going to say 10. I'm going to say 10.0.0. We're going to say 1.0/24. And then on this one, it would be 10.0.2.0/24. And then on this one, it would be 10.0.3.0/24. All right. And then on this one, this will be 10.0.4.0/24. All right. They're looking pretty good. And then this one, yeah, I need one. This one, 10.0.5.0/24. And then that's pretty good. And then inside of these, so this will be 10.1.1.0/24. Okay. And then this will be 10.2.2.0/24. And then this one would be 10.3.3.0/24. And yeah. Yep. Yep. That's pretty good. Okay. So this is what we're gonna do as our addressing. All right, for what we got here. So this would be our actual plan that we're going to be using for this network. So let me just write this down real quick. So we have I don't need to write that. I'll pretty much remember it all. Yeah, we're good. All right. So let's let me write that down. So the WAN link had to be 111.111. 0.4, and then the WAN, and then inside local inside 10.0.0.0/24, and then off of so that'd be off of VLAN 10. I'm gonna say 10.0.1/0/24. And I'm gonna say off VLAN 20. Say 10.0.2.0/24. And off VLAN 30, we're gonna have 10.0.3.0/24, and then off of VLAN 40, 10.0.4.0/24, then in server area, server farm, that'd be 10.0.5.0/24. Then area 1, that'd be 10.1.1.0/24. Area 2, 10.2.2.0/24. Area 3, 10.3.3.0/4. And that's it. That should be, yep. So what I just kind of did, guys, is again, we created our subnet. We're subnetting right now. So we gotta first think about what our topology want, kind of like what are the needs of our topology here. All right. And I'm keeping this very, very broad and very basic, so it's kind of easy. First off, I hope it's easy. It's coming across understandable. And secondly, we're not getting too complicated. We're gonna get a little bit we'll get more complicated tomorrow. With ensuring that we're only given point these links here, so we don't waste too many. Because right now I'm wasting a lot of addresses. I'll be burning through addresses here, but at the end of the day, it's really not going to matter with this kind of, well, it does matter, but just to keep things simple for now, this will help us keep it simple. So I just want to make sure I got all my areas. Yep, so I'll get all my areas, and then I got my VLANs that we're gonna have to make. We're also going to need a VLAN 1, but that'd be within that address range there. Let me just write VLAN 1 in there. All right. VLAN 1 will be 10.0.0. What's it going to say? I'm going to say 2. That's fine. Mm-hmm. I'll let DHCP actually do VLAN 1. I got area 4, right? No, VLAN 4. Okay. All right. Let's erase all that. Now let's configure our links here. So let's come over here. So that's the serial interface. Let's go to the command line. All right. Let's go into the first interface. So interface 0-1/0. Let's give that the IP address. All right. And what do we say? That's going to be the all ones. All right. So I want to say 111111/11/11. We're just going to say 2. All right. 255.255.255.0. All right. We're going to give that the old no shutdown. And we'll give that a description. And one text messages at the same time. Let's give that description. I'm going to say WAN outside. Go into this one real quick. All right, now that's up. That description and side. All right, that's done for that one. And that's the only one that we got to do on that one, so that's good. So let's exit now, and let's just do it right. Very good. Close that one down. Let's bring this one back up. So now that's up. That interface is up. Now we can ping. We can ping our other. We can ping the internet. Let's ping the internet. All right. So boom. So there we go. So we successfully now can communicate with the internet, quote unquote. Okay. So done. So now we got to configure our what is that? Gigabit 0 dash. Yeah, 0 dash 1. 0 dash. Is it 0 dash 1 or is it just? Let's see it. 0 dash 0. Okay. All right. So let's go. Let's move into that interface. Gigabit 0 dash 0. All right, and that's going to be in the first address range. So that's 10.0.0.1. 25.25.25.0. No shut. All right, description. All right, inside local. All right, I'm going to say area 0. All right, so that's the first one. Now what I will do, I'm only going to give this a DHCP for that little area. Okay. So let's exit out of there. IP, DHCP, pool. I'm going to say net-0 network 10.0.0.0 25.25.25.0. And then I'm going to say default. I'm going to say 10.0.0.1. All right. And DNS. I'm going to say 10.0.0.1. All right. I'm going to say lease. Main network. Options. Let's look at options real quick. Exit. Now I'm going to enable OSPF2. So say router OSPF1. And then I'm going to say network. And then what I'm going to do is I'm going to say that all the whole entire tens area. Okay. All right. And now this is wildcard mask. So we're going to say 0, 255, 255, 255. Okay. I'm going to say area 0. All right. Let me exit. And let's give this a loopback address. So interface loopback. I'm going to loopback 0. IP address 1-1-1-1. 25.25.25.25. All right. And let's just do a do show run real quick. I just want to look at what we got. We got a quick DHCP. That's just going to be for VLAN. I should actually make it for all the other ones too. Let's do that. Yep. Yep. Let's do that. Or should I use that router as a layer 3? Decisions. Nope. I'm gonna do it all off of this router right here. And then I'll just make the VLANs on that other router. Then you'll see the magic. The magic. Okay. So let's move back into that other interface, gigabit 0-0-0, and we're gonna say point. Let me just look at my ranges here. That's okay. I can use. Is VLAN 1. What addresses am I not using? So we're gonna say 10 dot. Yeah, we'll just say 10.0, 10.10 dash. That will be, so this is going to be VLAN 1 right here. Yeah. Yep. Very good. All right. Right. Encapsulation, .q, and 1 native. All right. IP address 10.10.10. Dot 1. 255.255.0. Dot. And we're going to give this a description. And we're going to say VLAN 1. Yep. So I just got to remember that. You'll see why in a second. All right, so interface, gigabit 0-0-0.10 now. All right, encapsulation.1q, I'm going to say 10, and I'm going to say IP address. Yep. And we're going to say 10 dot, what's for VLAN 10? VLAN 10 is, yep, that one. Dot 1, dot 0, dot 1, 255.255.0. No shut. Description. VLAN 10. All right. That's good. That's good. Interface gigabit 0-0-0. 20. Encap. Q. 20. And say IP address. That is 10.10. 0.1. 2.1. 255.5.0. Dot. Description. 20. Okay. Interface. Gigabit 0-0-0.30. Encap. 10.1q 30 IP address 10.10.0.3.1. Yep, 5.5.0. Shut. No shut description. And that's VLAN 30. Now we just got one more VLAN to configure, right? VLAN 40, and that should be it. So interface gigabit 0-0-0.40. And that's going to be IP address 10.0.4.1, 255.255.255.0. Shut. Oh, wait, what happened? Oh, I didn't encapsulate it first. Encap.1q 40. IP address 10.0.4.1, 5.5.5.0, and shut. That description, VLAN 40. Right, let's exit. Now let's do some IP, TCP, and this will be net dash VLAN 1. Right, so that'd be network. That's the 10s, right? Yeah. Default 10.1. DNS 10.10.10.1. Okay, exit. P pool. This will be net dash VLAN dash 10 network 10.0. That one again. Remember 1.0.255.5.0 default 10.0.1.1 DNS okay, exit. And again, DHCP network. It might seem a lot right now, but it's not that much, guys. Network 10.0.2.0.5.5.5.0 default 10.0.2.1 DNS 0.2.1 good thing. Work 10.0.3.0 5.5.5.0 default 10.0.3.1 and DNS 10.0.3.1 exit DHCP pool net 40 work 10.0.4.0 to 5.5.5.0 default router 0.4.1 and DNS 10.0.4.1 Save that configuration and let's look at it real quick. All right. So we have our DHCP. Let's take a look, make sure everything's right and looking good. Yep, that's looking good. That's good. It's looking good. It's good. Oh, I think I see a mistake somewhere. I do, right here. On that one. I didn't set the network for that one. Check that out again. All right, better. I didn't have the network actually set for that. Move back. And then we have our interfaces here. I'm just checking to make sure everything looks good. And everything looks good. Hold on. Crazy guys. All right. Let's continue now. All right. So that's good. So that's up. Now let's come over to the switch now. Let's go to the CLI. All right. Now we just have to make some VLANs. So, let's do this. What? Which one? So that's out. It's gigabit 0 dash. So. Interface, gigabit 0 dash. 0 dash 1? I think it's 0 dash 1. Yeah, 0 dash 1. Right. Switch. Trunk. Switch port. Trunk. Do show trunk. Truck. Truck to show trunk. trunk. All right, so there it is. So we have our trunk is up. Very good. So let's go back. And now we're just gonna make some couple VLANs. So VLAN 10. I'll give it a name. VLAN 10 is going to area 1. All right. VLAN 20. Give that a name. We're going to say area 2. VLAN 30. Give that a name. Area 3. And VLAN 40. That's that a name. That's server farm. So what do we got for interfaces on that? All right, stay right here. So let's go to interface. Fuzz 01. Say switch port. Mode. Access. So switch port. Access. VLAN. That's 10. Now let's go to interface 02. And we're going to say switch port, mode, access, switch port, access, VLAN 20. All right, and let's go to interface. Let's go interface 03. Switch port, mode, access, switch port, access, VLAN 30. Let's go to interface 4. Switch port, mode, access, switch port, access, VLAN 40. And that should be it. So let's exit. Exit. Let's write that configuration. Let me just make sure we write this configuration. Yeah, now that's good. Command line. What interface is facing that switch? It's gigabit 0-0 on all of them. All right, so let's get started. So interface gigabit 0-0-0. I'm going to say IP DHCP IP address DHCP. All right. Shut. All right. We got our IP address. Very good. That's what I was waiting for. All right. So we got our address. So we're rocking and rolling. Very good. Now let's go to gigabit Ethernet 0-1. Actually, let's give this a description real quick. We're going to say, I'm going to say local outside. Local outside. Okay. Now let's go to interface. What is it? Gigabit 0-1. Yep. Gigabit 0-1. All right, let's give the IP address. Interface. Gigabit 0-0-. That's why. All right, IP address. And what's that area called? That's area 1. All right. 10.1.1.1. 255.255.0. No shut. Description. Inside net. Area 1. All right. Let's exit. Then we're going to do an IP DHCP pool. And we're going to call it area 1. All right. We're going to say network 10.1.1.0. That's the network, right, for that area? Yeah. Pretty easy. 255.5.0. Default 10.1.1.1. DNS 10.1.1.1. Exit. And router OSPF 1. Let me give this a loopback address real quick. Loopback. Interface, loopback. I'm going to say 2.2. The address 2.2.2.2.2. Actually, I'll give you this one. 1. Oh, okay. Yeah, so 1.1.1.10. It's bad. Okay. And then router OSPF 1. Network, that's all the 10s. All right. Look at that. We're already making adjacencies. Exit. And let me do ping 10.0.0.1 and boom. All right. So we're looking good already. We're in the money. Now I know I made a DHCP server for area 1. Now let's come over here. We'll select DHCP. address. Let's go to that. So this is now our address. Let's go to the desktop. Go to the command prompt. We'll do a ping 10.0.0.1, and we're already getting replies. Okay, so we're good. All right. Now, what I won't do is I won't make a DHCP server though on these routers for these two networks over here. Okay. All right. So what I will do is I'm going to make a DHCP server, this one, that will allocate addresses for area 2 and area 3. All right. That's what we'll configure. Okay. DHCP address 10.1.1.1. What is that? I'm getting the address conflict. It's not interrupting anything. We'll take it. We'll just make sure that if that comes up again, we'll have to investigate on why that's happening. All right. So let's come over here to command line, and that should be the same. Yep, it's the same setup. Let's come over here, do the same thing. Now remember, we won't configure an IP. We won't configure a DHCP server on this router here. All right. So let's go to interface, gigabit 0-0-0. We're going to say IP address DHCP. No shut. All right. We're going to give that a description. All right. I'm going to say inside. Local, what are we going to say? What did I say on the other one? Local inside. Local inside. Or is that local? That's local outside. That's local outside. Yeah, local outside. And then interface gigabit 0-0-1. That's going to be the IP address of what's that? 2. Yep. So 10.2.2.1, 55.0. All right, no shut. Description. It'll be local inside. Okay. That one. Now we have to give this the IP helper. The IP helper. We will wait on that one. We'll wait on giving that that one. And then let's just do this. Let's exit from here. Remember, we're going to go back and give the IP address helper, but we're going to statically configure the DHCP server with an IP address once we get over there. Then we'll go back and then add that to the configuration on this interface, okay? So let's do router, OS, let's give it a loopback address too. Interface, loopback address, all right, IP address 10.2.2.2. Oh. Yeah. What did I say on the other one? Oh, 1.20.20.20, 25.25.25. Is that what I did on the other one? It don't really matter. All right. No shot. Exit. Router. OSPF1. Network. 10.0.0.0. 0.25. 2.5. That's area 0. All right. And exit. Okay, we've got our adjacencies. We're good. This one now. All right, so interface, gigabit 0.0.0, IP address, DHCP, no shut, description, local, outside, if I could spell. All right, now interface, gigabit 0.0.1, IP address, 10 dot, that's 3.3.3.3, right? Yeah. 3.3.1, 5.0, no shut. All right, description, local, inside. All right, interface, loopback. Interface, loopback, 0. And we're going to give that the IP address of 1.3.3. Work 10.0.0.0, 0.2555. There we go, 0. Exit. And right. All right. Made our adjacencies, very good. That's up and running now. That's all set now. Now remember, I haven't configured a DHCP for these two areas yet, but for the most part, everything's up. You can even see all these adjacencies that are coming up as we're going along here. I'll even show you the show IP routes. And you can tell we're filling up our list of routes now. Okay. Now remember, a lot of these routes though are connected locally because of how we configured it. Okay. All right. But these ones that you see in the O's, so the all ones, the twos, the threes, those are the ones that those other routers, those are those parts of those networks. That's why you're seeing so many of these. So these are the inside. So these are the inside. These are the local inside addresses. Okay. All right. The local outside. These are all the local outside addresses. These are the local inside addresses. Okay. All right. So we have one more. Interface, gigabit 0-0-0, IP address, DHCP again. Shot, and give that a description. Local inside, local outside. Yeah. Interface, gigabit 0-0-1. All right, address, and that is the all fours, right? For the servers, no, that's different. Server farm, I want that. Okay. Server farm 10.0.5.1 5.0 and no shut. All right, description in local side. Okay. Exit. Yep. And then let's do a DHCP for just those servers. And we're going to call it server from. All right, I'm going to say network 10.0.5.0 to 255.5.0. Default, that's going to be 10.0.5.1. DNS, 10.0.5.1, and then exit. Too bad. Oh, interface, loopback, 0. IP address, 1-48-4. Done. Should be making an adjacency here in a second. It did. Very good. All right. Yeah. Big. Let's go to DHCP. All right. Now that's got its address. Okay. So it's 252. Okay. Good. Let's go to services. Let's go to DHCP. I'm going to say area 2, and that is 10.2.2.1, 10.2.2.1, starting, 2, 2, we're going to start at starting address can, you know, we're gonna say whatever. We'll say 10. That looks good. Yep, yep, yep. Yep, 50. Add that. Now we have to make another one. Say 3. That's going to be the 3.3.1. 3.3.1. 3, 3. That stays the same. That. That's all set for that now. Now, what was his IP address again? That was 5 dot. 5 dot, no, that's not. Yeah, it's 5.2. So 5.2, 10.5.2. Let's come over here. Interface. Gigabit 0-0-1. IP helper. Helper address, and it's 10.0.5.2. Yeah. We should be able to get an IP address now. Give it a second. Boom, baby. Knew it was going to take a second. All right. Cool. That's good. Now, look at that. I already got an address. All right. All right. That's sending those DHCP serve all the way there. Let's do the same thing. Interface. 0-0-1. IP helper. 10.0.5.2. Exit. Write that now. That's going to take a minute now. While that's figuring out, I'm going to save this all. Broken. Yep, look at that. So we already got IP addresses now. Very good. And, yeah. And we got IP addresses. You. Let's get you up. Go to your services. HTTP. And you already have, already got a couple on you. What was your email address? What was your address again? 53. All right. Go to desktop. Go to web browser. Put in HTTP s 19 slash, and that's 10 dot 0.5.3, and look at that. All right, so we got connections. Hello world. Got some of this cool stuff. Got an image. Cisco. All right. So as you can tell, our topology here, what we've created is an entirely is a network, all right, that we've subnetted in the correct way. And here's our subnets that we had to create for this network to be working here. Okay, so we have a WAN link. Okay, we have a local inside. Okay, this is our local inside. All right, now on that switch here, I just configured VLANs on that switch. Okay, I didn't give anything IP addresses on it. But what the purpose of what I did, and the reason why I kind of went big on this WAN inside router is I wanted it to dynamically address and create default gateways for the local outside interfaces. So on all the local outside interfaces, and that is represented by these interfaces right here. This is our local outside, okay? Because they're local to the area, they're local to the network, but they're on the outside. Okay, they're facing the outside. All right, that's what I'm saying right here. This is right here. This is our local inside. Okay, local inside. All right, and then this is local inside. Okay, all right. So local inside, local outside. Okay, all right, and then this right here. Yeah, so this interface would still be considered local outside as well. This is global inside. So global inside, obviously, and then this area, this whole area would be global outside. So global outside. This is global inside. All right, and then yes, inside, outside, local outside, local inside. Cool. Yeah, and that's the power behind subnetting, and what we have to think about. And again, this was a very easy. The way we subnetted this was a very easy way of subnetting it, almost like a lazy way of subnetting it. All right, because we lost a lot of addresses by doing it the way we did it, but we did it a very easy way, so it can nearly be understandable. All right, And like I said, we have connections. Let's look at our routes again on our WAN outs, on our WAN inside, our wide area network inside router. All right. And now we have a nice full table of routes here. All right. So this is our nice, beautiful table of routes that we have going on here. All right. We have a lot of, again, a lot of these are local to this router, because those are those local outside. So all the ones that you're seeing with the L and the C's, those are my local outside addresses, and then the ones that you're seeing with the O's, those are linked by OSPF. Those are my local inside addresses that OSPF had learned. Okay. All right. But we have communication. So let's look at the IP. Let me just see the IP addresses for some of these bad Larrys. 10 dot, what are you? Let's write that right here. You're 10.1.1.2. Cool. Now let's go down to PC5. Go to the desktop. Let's go to, let's ping 10.1.1.2. And we have communication. Cool. Very good. Very, very good. All right. And again, we only use these switches. So all the switches that we have in our topology here, we're using them just as layer 2 switches, okay? Layer 2. We didn't get into anything layer 3 because we haven't talked about layer 3 yet. All right. So these switches are only they're only acting as layer 2. Even this, the main switch right here, all I configured was VLAN. All right. We added, let me see, we added 4 VLANs, VLAN 10, 20, 30, and 40. We made VLAN 1 a trunking. All right. We made it a, we made the interface gigabit 0-1 for VLAN 1, the native VLAN. We made that a trunk port. That way, for the other VLANs, it can add those those tags, those VLAN tags. So all these local outside interfaces not only have communication between each other, but they also were able to get dynamically addressed by the WAN inside router here. Okay. All right. Now on the WAN inside router, we're gonna have to configure NAT network address translation on that router here, so we can have access to go out to the actual internet. Because what's the address on this WAN outside? What did I configure it as? There, 111.11. Okay. They cannot communicate with the outside internet. All right, because we're not able currently to, because everything inside of our network is all public, no, private. We're all privately addressed. Okay, everything outside of our network, that's the big internet, and that's public. Okay, so we need to add NAT. We need to configure NAT, network address translation, on the edge router, so we can take all of our public, all of our, I keep messing that up, all of our private addresses, all right, and be able to talk out to the public internet. Okay, so it's pretty much you're taking all your private addresses and then saying, okay, we're going to put all those private addresses, we're going to use that one publicly facing address, all right, to be able to communicate messages back and forth. All right. And yeah, so that kind of again, this was a real. Let me just make sure I save all my configurations here. This was a real fun lab, guys. I hope you guys really got something out of what we did here. This is cool. I'm just making sure I go back and save all of our configurations. Look at that. It didn't take us that long, and we created a whole entire network, guys. Get everything addressed right, working. These switches, I didn't touch these switches. The only thing I did was I gave them names. Let me just save that then. Going back and making sure everything's saved. Give this a little savey. Cool. All right. So that kind of covers, like I said, this was the easy subnetting that we just covered. And then tomorrow we're gonna get into subnetting with the harder prefix notations, okay? And we're gonna go over how to easily do that, so it's not so complicated for us to do. So what we'll probably do is we'll build a similar type topology as we have here, and then what we'll do is we'll build it so we're, instead of wasting so many addresses like we wasted here, we'll be a little bit more smarter about how we're doing our subnet plan. That way we don't waste any. There won't be any waste. Okay. And everything again, it'd be pretty much the exact same setup. Okay, but with a tighter subnet plan, a real tighter subnet plan. All right, not to make it complicated. It's the right thing to do, so we conserve the addresses, and we only give out X addresses to whoever needs what. You know, say area 1, they're only going to be, you know, at the max, you know what I'm saying, they only maybe have 10 PCs and a handful of printers and phones in there, you know, and so maybe they need only 30 addresses, you know, so we'll give them 50 addresses. You know, area 2 might be a bigger area, and we need to give area 2, you know, 200 addresses. You know, we'll have to figure that out. You know, we'll have to just figure out what are the needs going to be in these areas, so we can give them the proper addresses, the proper address ranges and stuff like that. So that's pretty much it, guys. Like I said, I wanted to do a kind of makeup on yesterday, and that's why I didn't want to jump into going over the book right away, because I knew this was going to take me some time to explain. Because subnetting is such it can be such a confusing thing at first, and then if you don't continue to keep it in your mind, you can nearly lose how to go about it. Like I had to just like I have to continue to refresh myself, so it just stays in my mind. It just continuously stays in my mind how to do this, how to figure out the address, especially once we get over to doing the hotter ranges, the quote unquote more difficult prefix subnet mass notation areas. And again, there's a trick to it that makes it easier, but you have to just think about what you're doing when you're doing it. That way, you learn it better. You just learn it. And then yeah, it's one of those skills, a perishable type skill. It's not like riding a bicycle where you can just jump back on it, but it's a perishable one where you have to maintain that, how to do it in your mind so you don't forget when you need it. Okay. And the CCNA cert, again, from what I read, from what others tell me, you need to be pumping out. You need to be able to get the answer that you need, the subnetting answer that you need within a minute or so, because you're looking at about 100. I think it's like 100 or so questions on that test, and you only have a certain amount of time for. So you got to figure you're only looking at maybe a minute and a half to come up with answers per question. So if you're dealing with subnetting, and if you're kind of still fuzzy about subnetting, the subnetting questions will bog you down to the point where you might run out of time on the test. So we're going to be hitting on subnetting a lot over the next couple of days. There is a similar testing that we're going to do. We're going to get over to that, and we'll do some more of that. I feel like we are going to have to spend some time on subnetting together, because again, I might not be presenting it in a way that is 100% understandable right now. I will promise that I'm going to continue on my presentation, so it will come off in a more clear aspect for you guys. So yeah, it's just something I have to work on so I can be better at this, going over this for you guys. So that's it. The teacher needs to be taught how to do it. Present has to really dive into how to do it, so when the teacher presents something, the students understand. I'm not saying you guys are my students. I'm just saying you are my audience, and I want to give you guys the due diligence to present this in a fashion that is understandable for you, because you guys are coming along with me on this journey, and I want you guys I want all of you guys to be CCNA certified by the time we're done with our studies here. That way, again, there's career opportunities. If you go on Indeed right now and look up network engineer, you're gonna see them, asking for CCNA, CCNP, CCIE, depending on the skill level that they're looking for, or so the skill level they're looking for people that have knowledge in Cisco network devices, voice over IP, wireless, pretty soon you're going to be dealing with SD-WAN. That's another thing we're going to have to dump too, is SD-WAN. That's software-defined wide area networks. That is touching on what I've been doing with my virtualization stuff, because that's the future of things and where everything's going with cloud-oriented networks and whatnot. But yeah, this was a real fun lab. To do up in Packet Tracer. And again, guys, this is totally free, Cisco Packet Tracer. I encourage all you guys out there to pick up you know, pick up your copy of Cisco Packet Tracer and you know, start plugging away. Make topologies. You know, make a topology like this, guys. Pretty, like I said, pretty soon I'll have my Discord. I got it almost the way I want it to be. Um, it's almost just there. Just give me a little bit more time, and I'll have my Discord exactly the way I want it to be. All right. But you know, there will be rules on the Discord server. You know, I don't want anybody disrespecting people. That is the last thing I'm going to put up with, is people trying to disrespect people or anything like that. There won't be any nudity. There won't be any, you know, stuff like that. It's, you know, it's going to be, you know, built around a community of folks that know about these technologies, that want to help support others, and are looking to gain more knowledge and just conversate about these types of technologies and these subjects. You know, I want it to be a fun experience, you know, for everybody, including myself. I want to build a community around what this represents, all right, and what it doesn't represent. It doesn't represent harassment. It won't represent exclusion. It'll represent inclusion. Everybody will be involved in this, all right. I don't care where you come from, what your background is. I want you to be part of my community. If you're willing to just be part of a loving, caring group of individuals that just want to support each other. Like I said, I have been touched by a lot of people, you know, that are close to my life, that are not close to my life, that have just shown me so much love, and I want to build a community around that love, and I want to entangle my community out with other communities to bring everybody in, so everybody, you know, this, because I feel as though there is something special about learning about these types of technologies, because these are the technologies that run our lives these days, okay? And what I mean by that is your cell phone, your laptop, your computer, Facebook, Twitter, Twitch, everything revolves around the internet, okay? And as we're going to be continuing into the future, more and more things are going to be depending on the internet, because it's just going to be continuing to grow. So when things grow, there's more stress, all right? And when there's more stress, things tend to break, all right? So yes, there's a lot of automation in this field that has already come, that's progressively getting better. But the thing is they're going to still need people to automate those automation tools, all right? And that's learning about Ansible, all right? That's learning about Docker, Kubernetes. So there's so many other things, cloud, Azure, AWS, Rackspace. There's so much, guys. And there's so much more that will come, that is going to come. And there will always be jobs in this field. I'm looking for jobs in this field. You know, again, I'm starting my first job tonight. Yeah, it's not in this field. But hopefully with the potential job in the post office, this will get me closer to where I want to be, in some kind of oriented field that gets me closer to where I want to be. But guys, yeah, I hope you guys have a good night. We're getting closer to Christmas. Get to my other scene here. And so yeah, guys, in closing, I hope you guys have a good night. I will see you guys again tomorrow, same time, 5 o'clock Eastern, 5 o'clock p.m. Eastern Standard Time. Again, I have to really, I need to think really hard on maybe adjusting the time frame of these streams, but I will keep you guys informed on that. All right, these ain't going away. These are part of my. This stream is part of my. It's part of my education. It's part of my actual study, because I've learned so much more because I'm pressuring myself to present this to you guys and you ladies. So again, I'm stressing to learn this stuff more because I want to not look like a clown when I present this to you guys. So, yeah. So this has been an amazing experience so far over the last couple of weeks since I've started this stream, and I have probably quadrupled my understanding because I'm forcing myself to make sure I come across as knowledgeable. I won't say I'm an expert. I am not an expert, guys. I am studying for this stuff. So don't ever assume that Joe knows it all. Joe doesn't know it all. All right. Joe is learning this with you guys. Okay. So I want to be humbled in that, and and I just hope you guys understand that's where I stand on this. Okay. So if there's any question that, maybe I said something wrong, I implore you to ask me so I can fix what I'm saying wrong. So because I need to know where where I might be stumbling or where I might be ill representing what I am trying to put out there as information. Okay, because I want to make sure I'm putting out the best information to you guys, because you guys deserve it. Like, again, you guys' time is precious. It's precious to me, and that's the way the cookie crumbles. So yeah, guys, this has been great. I've had a lot of fun tonight. I hope you guys had a lot of fun, and I'll see you guys again tomorrow night. Okay. All right, guys. Love every single one of you. Have a good night. All right.